So now let us see the entropy changes for various processes for an ideal gas. So number 1, isobaric process. So in isobaric process, pressure is constant. So we have ds is equal to dq reversible by T. So this S that is changed in delta S will be integral dqr by T. Now since the process is isobaric, pressure is constant, so the amount of heat given is Ncp dt by T, and this is equal to Ncp is Cp and dt is, we have from T1 to T2 suppose, so we have ln T2 by T1. So this is the expression for delta S if the process is isobaric. Now if isochoric process is there, isochoric means V is equal to constant, then again you see delta ds is equal to dqr by T, implies if I integrate both sides dq reversible by T. Now for a isochoric process, this is Ncp dt by T, and you see this is suppose T1 to T2, so we have Ncv ln T2 by T1. So this is isochoric process. Now next is isothermal process. Isothermal process. For an isothermal process, temperature is constant. So we have again used this relation, ds is equal to dq reversible by T, implies ds is equal to du plus work done dw by T, implies ds is equal to, if the process is isothermal, for an ideal gas du will be 0. So we have dw by T implies ds is equal to pdv by T, that is again equal to pdv, p is equal to number of moles nr, p is equal to nRT by V, T and dV. So this T and this T cancels. So we have ds is equal to nRdV by V. Now if I integrate it, I will get delta S nR ln V2 by V1. So this is the expression of delta S for an isothermal process. So different processes are there. We can have the fourth process as adiabatic process. Adiabatic process for which dq is equal to 0. So here we have ds is equal to dqr by T. So that is equal to 0. So for adiabatic process there is no change in entropy. So we have seen for different processes how the entropy in the system will change.